Hello, I hope you're doing good. This is 11.3. I worked through a few of these problems. I thought I'd just send you a video. You can do most of this on the calculator. And I wanted to just talk about a few quick things. First of all, first question, put this in your calculator, pay attention to your window, and remember that polynomials of degree 3 are going to have 2 turning points. Question 2. Question 2, put this in your calculator. Pay attention to your window. You should be able to find your answer there. 3, same thing. 4, I put this in my calculator. It'll select the graph for you. The function is increasing from 0 to infinity, and it's decreasing from negative infinity to 0. So be sure you answer that part. The x-intercepts of a function y equals f of x are the real solutions to the equation f of x equals 0. That is true. If g of 5 equals 0, then we know that when they used 5 in place of x, they got 0 for an answer. So the ordered pair 5, 0 is on the graph, and the x-intercept is 5. For the function f of x, find the maximum number of real zeros, the maximum number of x-intercepts, and the maximum number of turning points that the function can have. It can have 6 real zeros because that's its highest power. It can have 6 x-intercepts. You have to take the highest power and subtract 1 from that to find the number of turning points. So this one only has 5 turning points. For this function, find the number of maximum number of real zeros, maximum number of x-intercepts, and the maximum number of turning points. This one is degree 2. Even though it's not the leading term, it's still its highest power. So it has a maximum of 2 real zeros, 2 x-intercepts, and only 1 turning point. The graph and degree of a polynomial with real coefficients is given below. Determine the number of real zeros and the number of non-real complex zeros. Assume that all the zeros are distinct. So it's degree 3. I see 1 real zero. Each distinct real zero corresponds to an x-intercept. Non-real complex zeros do not correspond to x-intercepts, and they come in pairs. So this can have 1 real zero and 2 imaginary zeros. This graph of a polynomial is shown. How many real zeros does it have? It only has 1 because it only crosses the x-axis 1 time. The graph and degree of a polynomial with real coefficients is given. Determine the number of real zeros, then determine the number of imaginary zeros. Well, it's a degree 2, so it only has 2 zeros of any type. It doesn't cross the x-axis at all, so it doesn't have any real zeros. It has 2 imaginary zeros, because remember, imaginary zeros need to come in pairs. This one has 1 real and 2 imaginary. Since it's degree 3, it had to have 2. The graph of the polynomial is shown at the right. Determine the number of real zeros and the number of imaginary zeros. Well, if you look closely, you see that it has 1, 2, 3, 4 places that it crosses the x-axis. So it has 4 real zeros. It doesn't have any imaginary zeros. Here's 13. If you look, you'll see it crosses the x-axis 3 times, so it has 3 real zeros. Since it's degree 5, it has 2 more zeros, and they must be imaginary. The graph of the polynomial is given. It is degree 4, and I see 2 real zeros. So it must have 2 real zeros and 2 imaginary zeros. Determine the minimum degree of the polynomial function graph. Well, I see that it has 1, 2, 3, 4, 5 real zeros. So it could be degree 5. Okay, we put this one in the graphing calculator, go to the table, find the zeros of the function in the table, there's 3 of them. You could also find them from using the trace feature or the calc feature on your calculator. The graph shows us this. Remember, the factors would be x plus 4, because you would set the factor equal to 0, solve, and then that would be your 0, so that's why we get these for factors. And then this graph, the zeros are given, and the least degree it can have is 3 because it has 3 real zeros. I hope this helps.